If you've seen my other videos, you know about the massive capacitors that are inside of this power supply. So you're already quite aware of them. Back to 0. Okay, leave E-stop active. And then we're going to look over here. A newer cap bank I'm building. It will have an integrated resistor at some point, but this is just for testing the charge on it. So I'm going to load it up. And we're going to see how long it takes to discharge the internal caps of my power supply as well as this behemoth. So if you haven't seen the other video, again, there's a ton of capacitors inside this. I'm going to take off E-stop. So the resistor that was shunting the capacitors and the load, which was going to those guys as well. So there's a resistor across everything on the DC bank, is released. We've got power and everything selected, and this is going to show DC voltage. So turn this up, you're going to see AC current go up, going through the rectifier circuit, charging the DC side. Okay. Fully charged. Now, we're going to E-stop it. I want you to watch how long it takes the voltage to drop to 0. There's so much current. Oh, this should be, the math is right. This is a kilojoule of energy that just got dumped. So all these capacitors together, it's an entire kilojoule. It's such a stupid amount of energy. This is so stupid. Anyhow, yeah. So this ammo can is going to have some wood blocks in it to keep the capacitors in place, and then there's going to be a integrated shunt so that whenever it's not powered, the relay will leave it in a normally closed position, just like I did in the other box. So it's always shunted to a resistor when it's not in use, and then I'll have a separate set of leads, basically an enable circuit, so that when that circuit is powered like 24 volts or something, it'll close the relay or open the relay that'll release the shunt resistor, and then these things can be used as normal caps. So I plan on having 4 leads on this, where you've got 2 high current leads straight to the cap bank and 2 low current to the control relay that will disable and enable the shunt resistor I'm going to install in this ammo box. So there you go. I decided I needed a voltmeter. 196 volts DC this is 1 kilojoule. That's ridiculous. 1 kilojoule at 196 volts. I'm going to go hit the E-stop so we can watch this fall. All right. It's so crazy. I mean, at least the E-stop shunt circuit functions as designed. The amount of energy in this thing is stupid. It's just stupid amount of energy. It's crazy. Okay, one of the coils in this transformer is 4 ohm. Gross. Let's open this up. I don't want to smell that. Ran it till she popped. All right, so this is a construction pencil, and it's a thicker lead. So I've shaved the back of it so I can connect it to the clamp, and I've got the front here. So basically, we're going to be conducting through these 2 graphites. Let's see if I get to focus on that tip. And then I'm going to have to wear my shield while I do this because it will generate quite the UV. So I will need my face shield. Welding hood. This is a proper carbon arc lamp. DC power supply is on. We're at about 100 volts DC. Ooh. All right, I gotta de-energize this. So obviously the wood cannot sustain the heat generated by that. We're still draining out. I'm gonna drop this into my bucket of water, which we'll miss. And let's put this in the bucket of water as well. Oof. In you go. So. That is a carbon arc lamp. The most ghetto carbon arc lamp ever. Let me see if this thing's still hot. Can I pick it up? Ooh, it's still a little warm. It's made the paint boil on the construction pencil. I don't know what it looked like without the welding hood on. I'm gonna throw that in the water too because it's quite spicy. So let's see what it looks like in the video. Okay, we're gonna do this one outside and I'm gonna load it up and we're gonna see what happens. Well, the answer was it acted like a fuse. That was kind of crap. All right, so here I have another construction pencil I have shaved down on opposing sides to expose the graphite. So what we will do is we will put it between the electrodes and load it up and we'll watch what happens. And I'd say it's disintegrated. What I hadn't showed you yet is my ghetto add-on capacitor. Earlier, connected to everything. We're going through this capacitor. Helps the power supply catch up with surges, especially when doing the striking of an arc. Because, you know, it's a lot of current all at once. And if you can keep that current up, then you get the arc and it'll pick up and you can do the start. Well, this is rated, there are 6 12,000 microfarad caps in here, each rated at 350 working volt DC, 400 volt surge. And I have one of those old military spec 1,500 watt 22 ohm resistors in here. So this is a storage. I was talking, I don't know if I'll make it in the video, but I mentioned in one of my other commentaries I've recorded that I was considering having a second power input to like make this automatically turn off whenever the other system's in place. I'm like, well, then I gotta plug another wire up. I'll just make it a switch. So when the switch is off, then there's nothing connected across. So this will just naturally collect some charge like capacitors do, especially at this size. Flipping this on shunts this capacitor through this this big freaking resistor in here. So I'm gonna pop this ammo can open. So I drilled some bulkheads on the side, and I'll show how silly this thing is on the inside. So there's not really a whole lot in here to see, obviously. There's the massive capacitors I mentioned, connected with a bus bar I basically cut from some galvanized steel, and you know, I've got some bolts tying it all together, and then you see the giant resistor here, everything, so I can just, you know, fire it, and it will keep this thing drained, or it will drain it if I need to drain it out of circuit. But for storage, it just is basically constantly shunted through that resistor. When you flip the switch off, it, you know, takes the resistor out of circuit, and then you have a giant floating capacitor. You can just connect things to those leads right there, and then go all the way to the other side, which has foam on it right now, but there you go. And you can see the ends of those are burnt from the piece of wood that I burned earlier. And yeah, that's it. Giant capacitor, ready to go.